Hello, ladies and gentlemen, Root Beer here, and I thought I would look at the most basic of all the Apollonian problems. How do we get a circle through 3 points? Okay, now I've covered this before when I did my straight edge and compass constructions, and what we're going to do today is basically going to be the same thing, but I won't be limiting myself solely to just drawing lines and circles with a given center, just because I've already shown you guys in the past how to do things like construct a perpendicular line, a perpendicular bisector, angle bisector, things like that. So we'll be taking those for granted throughout this series of constructions. So this will go a little faster. So say you've got any 3 points here in space. Now, you can, even if you know some just some basic geometry, you've probably heard that you can get a circle through any 3 points. I think I've said in the past, any 2 points determines a line, and any 3 points determines a circle. In fact, GeoGebra even has a tool that does this. Okay, but we're not going to use that tool. But we probably will use it going forward. But here's our video showing that this is a perfectly reasonable construction. All right, so what do we need to do? So we given our any 3 points, we're going to construct perpendicular bisectors between pairs. You don't have to do all 3 possible pairs, but you can. And any 2 of these perpendicular bisectors will intersect at this nice little common point. All 3 of them actually run through this point, and this point here is going to be the center of our circle. So we take the center, and it's the center of our circle, so really choose any of these points, and you get yourself a circle. So we'll hide the extra stuff. This one's just an application of can you do perpendicular bisectors, and I've shown you guys with circle straight edge constructions how to do that. So we're just going to use the GeoGebra tool for that. But here we go. We get a circle through 3 points, and as I mentioned, GeoGebra does have a tool to do this. I will be using that tool in future when we do things like point, circle, and so forth, just to speed things up. Same reason I'm using perpendicular bisector rather than, drawing 2 circles and connecting their intersections for perpendicular bisectors. I've done that in the past. It takes a while. We want to do this a little quickly because it's about the constructing of the circles, not the can we do all the nitty-gritty from very basic first principles, straight edge and compass stuff. One thing I'd like to note, and I won't be dwelling on this a whole lot as our Apollonian problems get more complicated, but there are certain cases where things just don't work. For example, and I'll see if I can get GeoGebra to do it now, but if our 3 points are collinear, we can't actually. It doesn't look like I can get it to work. But if our 3 points are collinear, they all lie on the same line, you can't get a circle running through all 3 of them. You see, as our points become more collinear, our circle's getting bigger and bigger and bigger. And if all 3 points do lie on a line, you actually get a circle of infinite area, which isn't really a circle at all. Okay, you may have seen this construction before, not with points, but with triangles. What we've really done here is just drawn the circumcircle of a triangle. That's all we've done here. And connecting back to my previous point, if you don't have a triangle, if it's degenerate, if all 3 points lie on a line, you don't have a triangle and you don't get a circumcircle. Okay. But there we go. That's our most basic of the Apollonian constructions, and it's something we will take for granted as we go forward. You know what? Let's just very, very briefly. And we have 3 points. These guys lie on a line. What happens to our construction? Well, we'll hide this fella. What would we do? Well, we'd want to use perpendicular bisector. Okay, but because they lie on a line, these 2 perpendicular bisectors, they're both perpendicular to the same line, the line that goes through all 3 points, and so they're parallel. They will never, ever intersect. And we needed that intersection point to get the center of our circle. That's the problem there. Okay. But as I say, we're doing general constructions, and in general, you don't get 3 points line on a line together. Okay. So that's about it. Join me in the next video as we look at another harder Apollonian problem, and I will see you guys there. Thanks for watching.